I'm always just trying to do something outside of school as an engineering student. And one of those ways is I'm volunteering at this place at the canine organization down the street. And they had me assemble these crates a couple days ago. And basically, what you do is you have the bottom tray and you have the top tray. And then you put these screws in. You have a screw in the bottom, and then you use these knobs, these little nuts, and then you tighten them down. And there's like 10 of them. And they do them by hand. And they do a lot of crates because they have a lot of dogs, obviously, and they ship them out all over the country. It's pretty neat. But the crazy thing is, these things are the cheapest things. And when you're tightening them down, you have to tighten them all the way down. You can't just spin it and then it goes all the way down like a nut. You have to just constantly twist it, and the screw is really long, and it's a big pain in the butt. One, it wastes a lot of time, and two, it starts hurting your fingers, and it's just not a good thing. So my creative thinking mind, I was thinking, we need to do something else here. So I was thinking of kind of like a socket. You attach it to a drill. We've got a drill right here. You attach it to the drill, and then you put your nice little tool in here, and you install it, and you're set to go. But a socket, I don't think is going to be the perfect fit for it. So right now, my design for this is going to be 3D printing it, and then I'm going to install it on the drill right here, and then I'll make a custom socket piece like that will fit in here perfectly, because what you see here is there's 3 different sides. There's 1, 2, and 3. And you can see it curves out right there. So what I want is I want a nice perfect little circle that's going to fit in there. So let's get started. That'll be pretty neat. And the maintenance guy Jim's going to be pretty excited about it. At least I hope so, because I didn't tell him. So I got a little, before I always go on my computer, I always draw on a piece of paper to just kind of get a 2-dimensional feel of it and kind of get some dimensions. And the first thing I kind of want to measure is the circumference or the diameter of it. So doing that, I don't need these to be super accurate, but I want it to be pretty accurate. So I'm just going to place it in here. And doing this, I'm not going to get the circumference because it's a triangle. So what I'm going to do is I'm going to twist it in there. And just by doing that, it doesn't need to be 100% exact, but I just want it to be nice and loose for it to fit in there. And so for the diameter, 0.692 inches. Sorry if you like the metric system. This is in inches. You just have to deal with that. And then the next part is when I have my sphere or my cylinder, when I set it in there, I need it to be locked in. So when I twist the drill and move it over, it's going to lock in there and start tightening down. So what I'm going to do is install or build on here 3 little sphere or cylinders, tiny little cylinders that will notch into there. So kind of like this. And those cylinders will be 120 degrees apart. So we got 1, 2, and 3, and then that's just showing it's 120 degrees apart. There's your diameter for you. So yeah, this is where you're going to install it, slide it in there, and then I want something like this shaft that's going to go on the back of it so it can install it on the drill. And this is 3D printed, so I think I want this a little bit thicker. So let's just measure this. 0.35. So it's going to be a little bit easier to grab on there. And that side right there is 1, 2, 3, 4, 5, 6. So it's a hexagonal polygon, 0.35 inches. Alright, so let's get started on here. We're just going to start the sketch on one of these planes. We're going to start with a circle with the center point. Start in the center right here. And we want that diameter to be, we already measured it out on our little piece of paper, 0.692 .692 inches. And then that's the smallest part where the inside wall is going to touch, but we want to build an outside wall. So I want to make the outside wall, you know, sort of thick. Remember, we want it, this is going to be 3D printed, so like the wall thickness should be 0.15, looks good. So add 0.1, so 0.85. And then there's our wall thickness right there. And then we're going to go over and just make 3 little, or just 1 little circle on the edge right here. And we're just going to make this an arbitrary height. At the maximum, it looks like we want it to be about 0.2 at the max. So dimension that. So it's 0.236, so let's make it 0.19 just to be safe. And then they have this really cool thing. You go over to sketch. You don't have to do any math. You click what you want, and then you click the center point for it, and then you can change how many circles you want. But we will only want 3 because that's exactly kind of how our shape is right here. So we're going to make it 3, click OK. And we are set. So let's stop this sketch and do an extrusion right here. Let's see what this piece kind of looks like. And then for how tall do we want it? We kind of want to look exactly how tall that should be. We want to be able to place it in there. And then if we need to pull it out, we can pull it out a little bit. So I'm thinking just leave this top part up. So that's about 0.65. And remember, these measurements don't need to be exact because I don't want this to be like perfectly tight in there. You want it to be a little bit loose in there so you can place it in there quick and then just zip it down with the drill and you're done. Perfect, now we're looking pretty good. And right now, if I set that piece in there, it would just slide right through. So we need a back plate. So let's go back to our sketch. Over here, we're gonna show that sketch. And pull it on the angles side so you can see it. And then now we have a base plate. Let's make that 0.2 for thickness. So now we essentially have our socket, which is pretty neat. You're going to be able to just place it in there, and then you're set to go. But last thing is to get the shaft so we can attach it to the drill. So go over to sketch again. They have this neat thing for polynomials. Click on the plane we want to start drawing on, and we lucked out twice. This is a hexagonal polygon, so we're set. And for that diameter, we decided we want to make that 0.35, but this is the radius. So about 0.17. And we are set. So let's stop that sketch. We're going to modify, pull it out. And I don't want it to be too long either because, once again, it's 3D printed, so I don't want it to be too fragile. If it's too long, it might end up breaking. So the normal size for these kind of shafts is right around 1 inch. So let's make it 1 inch, 1 inch. And then this is basically done. We could 3D print this and try it out. But before we want to do that, I just like to make all these edges look really clean. So we go over here and click on modify, fillet, and I'm just gonna make all these edges perfect and make them clean. 1, it makes it easier for the 3D printer, and 2, it's not as easy for it to break. So if there's a little fillet there, it won't just rip off as easily. So That's a little too big. Let's make that 0.05. Perfect. And then we're also going to fill out all the other edges, the outside edges. We just want to fill it those nice and small. And it looks like one of our extrusions for our outside circle came through. I'm just going to modify that and pull that away. Cut that. That's out. Fix that edge. Fill it. And then we're looking pretty good, so we want to keep those edges pretty sharp. That's what it looks like right here. And we got it rounded over here. You know, everything's looking pretty good. So now all we need to do is 3D print it and try it out and see if it fits.